On a sunny afternoon, a standard aluminum pool enclosure is the perfect Florida backdrop. It's clean, quiet, and does exactly what it was designed to do: keep the leaves out of the water. Most homeowners assume that if the frame is straight and the paint looks fresh, the structure is perfectly capable of handling a storm. But underneath that surface, stress fractures and intense chemical reactions are often quietly eating away at the joints holding the entire frame together. This red arrow tracks the actual debris trajectory recorded during forensic inspections. In a high-wind event, a compromised frame launches aluminum members directly over the roof of the main house. This vulnerability often stems from a decision to prioritize the lowest initial quote or a cosmetic upgrade over engineered resilience. To identify a failing structure before the wind picks up, engineers look for 3 specific indicators of hidden damage. Recognizing these signs allows you to separate a reliable protective envelope from a structural liability in your own backyard. The first issue begins with a common request: upgrading the screen mesh. Standard 1814 fiberglass mesh is highly permeable. It is designed to let a large percentage of wind pass straight through, which keeps the aerodynamic load on the aluminum frame relatively low. This diagram shows the difference between standard mesh and tightly woven upgrades like Florida glass. Swapping the mesh converts a permeable screen into a solid sail. These red arrows illustrate the massive increase in pressure pushing directly against the aluminum framing. Without re-engineering the frame to handle this new load, the structure will experience racking. As seen here, the entire cage leans into a parallelogram under the pressure. Stopping this collapse requires specific structural reinforcements: thick aluminum K-braces in the corners and diagonal high-tensile steel cables to distribute the tension across the roof. Treating a mesh upgrade as a simple cosmetic change leaves the structure unprepared for the reality of hurricane-force wind loads. The next indicator of failure is hidden inside the joints where the beams meet. When standard stainless steel or galvanized screws are driven into an aluminum frame in Florida's humid, salty air, it triggers an aggressive electrochemical reaction. Stainless steel forces the surrounding aluminum to act as a sacrificial anode. Over time, the aluminum threads dissolve into a useless white powder, stripping the joint of its holding power. Standard galvanized screws fail differently. Once the salt air strips away the zinc coating, the steel core rusts and expands, exerting enough internal pressure to physically crack the aluminum casing. This diagram highlights the modern solution. On the left, the standard screw completes the destructive galvanic circuit. On the right, engineered fasteners use a sealed nylon cap and an anti-corrosion barrier to electrically isolate the metals and break the circuit. Relying on standard hardware creates an invisible battery that quietly ensures the sudden failure of your enclosure's structural connections. The final vulnerability is at the base, the foundation. Many homeowners prefer building directly over decorative pavers, but as shown by this orange dashed line, pavers resting only on sand or dirt provide no structural support. This design offers zero pull-out resistance when the enclosure is subjected to the massive uplift forces of a hurricane. Current building codes require deep, steel-reinforced concrete footers poured specifically to bear these structural loads. The choice of anchors matters as well. Basic mechanical wedge anchors are prone to rattling loose after hours of sustained wind vibration. Proper installation requires chemical anchors, where a hybrid acrylic adhesive is injected into the concrete to bond the metal plate directly into the foundation. A beautiful patio floor is structurally worthless if the enclosure is essentially floating without deep chemical anchorage to resist the storm. Understanding these risks makes the municipal permitting process more than just a hurdle for builders to clear. Bypassing the notice of commencement means opting out of an independent engineering review of the entire structure. This review verifies the mesh aerodynamics, the footer depth, and fastener chemistry all meet the required safety standards. An unpermitted structure is almost certain to fail the rigid wind load criteria established in the state building code. The real-world consequence of ignoring these engineered codes is visible in the aftermath of every major storm. A municipal permit provides the definitive, legal confirmation that every calculation was verified by a third-party engineer. You can evaluate your own enclosure with a simple checklist. Ensure your K-bracing matches your mesh, look for Nylo-Tec fasteners, and verify chemical anchors in a concrete footer. These structural elements represent the absolute baseline for survival in a modern Florida hurricane zone. Screen Factory Florida integrates these rigid standards into every project, moving past the surface appearance to focus on actual resilience. Their commitment to modern solutions, timeless quality, means prioritizing physics and engineering over cheap, unpermitted work. It replaces the anxiety of hurricane season with the peace of mind that comes from verified engineering. To find out if your current enclosure is secretly failing, you can request a free structural assessment and 3D visualization from Screen Factory Florida. Taking 30 minutes to verify these details today ensures your enclosure is built to hold, not just built to look good.